One giant chip, one tiny defect. Total loss.
So engineers rebuild chips like Lego. Shrinking got slower, and power density stopped playing nice.
Large dies fail more. Smaller tiles survive.
Chiplets are specialized dies that snap into one package.
Put compute on cutting-edge silicon and leave I/O on cheaper mature nodes.
Packaging climbs a ladder from simple boards to stacked 3D systems.
CoWoS sits logic and HBM on a silicon interposer for insane bandwidths. EMIB uses tiny silicon bridges only where dies need to talk.
Hybrid bonding fuses copper to copper for ultra-dense connections.
UCIe is the open wiring standard for chiplet packages.
The spec is ready, but a true mix-and-match marketplace is not.
AMD Genoa can run 12 compute tiles around one I/O hub for up to 96 cores. NVIDIA Blackwell unites two max-size dies with about 10 terabytes per second of chip-to-chip bandwidth. Apple Ultrafusion glues two max dies with 2.5 terabytes per second of interconnect.
High bandwidth memory stacks ride beside the logic, not far away on a board.
For AI chips, advanced packaging capacity is often the scarce resource.
Follow the money from EDA tools to designers, foundries, HBM, OSATs, and equipment. Designers and foundries include names like AMD, Intel, NVIDIA, Broadcom, Marvell, and TSMC. Packaging and tools map to AC, Amkor, SK Hynix, Micron, Applied, and BZ.
Analyst chiplet forecasts disagree wildly, but the direction stays up.
Heat and testing get harder when many dies share one package. Assembly yield and packaging capacity can still break a beautiful design.
Modular silicon wins, and packaging is a core bet.
This video is educational only, not investment advice, so always do your own research.
If this helped, like, subscribe, and drop a comment with your next tech topic.
Chiplets are semiconductor Lego, and the rebuild is already here.